Hey guys, it's Miss Davis, and I'm back with another lesson. We're doing the pre-algebra review. We're not doing any more homework info. This is part 2. All right, we're doing order of operations. So order of operations, you should know as, and some people learn it a little bit different, but pretty much I think most middle schools teach PEMDAS. Some teach GEMDAS, where we start with grouping symbols, but basically this is parentheses, exponents, multiply, divide, add, and subtract. And believe it or not, my advanced kids have trouble with order of operations. I'm not quite sure why. So if you find that you're struggling with this, know that you're not alone and never have been and probably never will be, but it is something that you need to work on. Own it, love it, it's yours. Oh, look, there's some words. Perform order of operations in parentheses. Evaluate numbers with exponents. Multiply or divide from left to right. Add or subtract from left to right. So here we go. We do not have any parentheses in M. We do not have any exponents in M. Even though subtraction is first, that doesn't matter. We are going to multiply. We're going to multiply -5. You can treat it like subtraction, or you can treat it like a negative. It's up to you. -5 times 6 is -30, so you can do 20 and a -30, and now switch to subtraction. Or you can do 20 minus 5 times 6 is still 30. So I have my 20, I have my minus, and I have my 30 now. So there's a couple different ways you can think about it. But now we're going to do the subtraction. 20 minus 30 is -10. So remember your order of operations. Again, this is something that comes up quite often as we go through, and I'll be like, hey, remember lesson 0? And you're going to be like, maybe. All right, let's look. Do we have any parentheses? I don't see any. Do we have any exponents? We do. We have a 4 squared. So I'm going to rewrite the problem. I'm going to replace 4 squared with 16. It's 4 times 4, not 4 times 2 or anything like that. And then I'm going to write the rest of the problem around it. We're going to do the multiplication and division. So with the multiplication, we're going to be multiplying here. We can also do division in the same kind of step, in the same kind of line, because they're kind of individual. And then what we'll do is we'll add those two values together. So 12 times 3 is 36. 16 divided by 8 is 2, and now we can add 36 and 2 and get 38. You can put these things in the calculators. Calculators have tried or have been programmed to follow the order of operations, but you should know how to do these because they're fairly simple. All right, let's look at O. We're going to do in our parentheses. Now we have 2 sets of parentheses, but this set of parentheses right here, it's kind of, there's only a -3 in there. They're more there for the fact that they want you to not lose that negative. These parentheses right here, though, we can subtract with them. So 7 times 5 minus 3 is 2, plus, you could at this point, because we've already taken care of our parentheses and the 6 squared is kind of on its own, you could go ahead and convert that to a 36, but probably try not to do too many things all at the same time. I can do my multiplication here. I can also do my division here and then do my addition. So 7 times 2 is 14. Plus 36 divided by -3 is -12. If you want to wrap that in parentheses, you can. It's not required. It's just kind of a thing that they chose to do. 14 plus -12 is 2. It's the same as subtracting 12. All right, so here we go. You try. Pause the video. All right, you're back. So let's look at 11. Don't have any parentheses. I do have an exponent, so let's take care of that. 4 squared, 16. Now, you can do multiplication and then division, but in this case, I might do the division first. So I know we teach it from left to right, and that's usually because we want to make sure that everything gets combined properly. However, You might not know what 5 times 16 is and then divide it by 8, but you might know 16 divided by 8, which is 2, and then be able to multiply that by 5. So it might be one of those things where there might be a shorter way. It doesn't necessarily follow the strict rules of order of operations that we had outlined there where it said from left to right. Just be aware and be cautious as well. All right, there are no parentheses in 12, but we technically have a grouping symbol. So we have numbers that are grouped in the numerator and they're grouped in the denominator. So because of that, we would want to work those pieces first. So 2 plus 4 is 6. 1 minus 5 is -4, and then we've got -1. We could convert 6/4, we could simplify that fraction to -3/2 minus 1. And you could change it to a decimal, but remember, we've got fractions, so we really want a fraction answer. So the nice thing would be to get a common denominator. So we should multiply this 1 by 2/2. And we end up with -3/2 minus 2/2. And they have a common denominator. -3 minus 2 is -5/2. So that's what I would say my final answer is. All right, 13, we're going to do the parentheses first. I'm going to go ahead and change 8 squared to 64. I'm going to multiply. We get 44 minus 64 divided by 32 is 2. 44 minus 2 is 42. All right, you are expected to be able to solve 1- and 2-step equations. That's something that you should have worked on in middle school. We're going to do multi-step, but let's play around with some 1- and 2-step problems. So remember, the goal is to solve for the variable. You're going to do opposite operations to isolate the variable. So for problem P, my variable is x. I see a -9. The opposite of subtracting 9 is adding 9. Now, as I go through here, I'm modeling the work that I would like to see for these types of problems. So the -9 and the +9 end up canceling. You don't necessarily have to cancel that part out. I'm going to use it in this example as something that you can do. But when that happens, it basically turns to a 0. There's nothing there in that spot and only an x on the left-hand side. Then I want to add that 9 to the 24 and get 36. So I expect to see, what are you moving? How are you moving it? I should expect to see symbols. I expect to see numbers and you showing me what's going on. All right, let's look at Q. Nobody likes Q. Also, look at you. Nobody likes you either. I like you though. I like you. You. Anyway, I'm trying to be funny by myself, but hopefully you're kind of smiling a little bit. All right, so a lot of people will try to do this. I'm dividing by -5/6, and that just ends up looking terrible. I'm just going to go ahead and say it. That's gross. So what we did in the last video, one of the things, remember, it was simplify your fractions. Don't divide by fractions. We're going to multiply by the reciprocal. So we're going to, instead of dividing by -5/6, what we're going to do is we're going to multiply both sides by -6/5. Now let's look at what happens there. This is always, anytime you have an integer or a whole number, it's always over 1. So you might need to write that out. But here, when we multiply, we get a -6 times -5, that's a 30, over 5 times 6, which is also 30, and 30 divided by 30 is 1, right? So these cancel, leaving behind a 1t. Okay, so that is the goal of multiplying by the reciprocal, is to get this to cancel with this and leave behind a 1t. Now when I multiply over here, I've got a negative times a negative, that's going to be a positive. I can reduce if I want to, it might be a little bit helpful. And I can see that I've got 18. You could also do 15 times 6 or -15 times -6 and then divide that by 5. There are lots of ways to approach these types of problems. All right, R, you have variables on both sides. So I want to get a variable to move. So let's say there's a positive 1x there. I want to subtract 1x or subtract x, and I want to move that over. Now, when I subtract things, let me change this. When I subtract things with variables, I'm just combining their coefficients. The coefficients are the numbers in front of the variable. So these guys cancel. 1 minus 1 is 0. I have 5 equals, and then 11x minus 1x. The x is still going to be there. What is 11 minus 1? It is 10x. Okay. Now some people freak out because they've been trained that the x has to be on the left side. So if you want to do a quick rewrite, you can. But we're solving for x. We want to get x by itself. It's x times 10. So we're going to undo, multiply. We're going to divide by 10. And 5 divided by 10 can reduce to 1/2. Okay, so all of this stuff that I'm writing out for you is stuff that I want you to be practicing. And when I say you're not showing your work, that means I'm not seeing this stuff. I need to see evidence of what changes you made. All right, let's look at S. I see a minus 3. I'm going to add 3 to both sides. That means I have 4x equals 16. Divide by 4. X is 4. Over here for t, I'm going to subtract 46. Now, there are multiple ways. It's not only one way to solve a problem. You might come up with a different way, but you need to show me how to do it. All right, so I subtracted and I got negative x equals 35. This is a negative 1x, so I'm going to divide by negative 1. You could also just say, well, I'm going to change the sign. That also works. But there should be some evidence of what is going on. All right, U. Remember, I like you. I like you too. All right, so a lot of people don't like that divide by 3. So one of my common things to ask is, if you don't like division by 3, how do you get rid of divide by 3? And the answer is multiply by 3. Now you're really multiplying by 3 over 1. So when you do that, you're canceling here, and you're not going to have any change to that numerator at all. So make sure that if you are multiplying by 3 to cancel out the divide by 3, it actually truly cancels. It doesn't affect the numerator. We're going to have 15 plus h equals 30. And then we're going to subtract 15. And h equals 15. So again, I want to see work. I don't want to see plugging in numbers for variables to check and see that it's right before you've actually solved. You can do that at the end. But I want to see work. I want to see opposite operations. I want to see how you are going through and solving for the variable. Okay, so I have some good examples here, and that is what I expect to see from you, more of the same. All right, so here, pause the video, you try. All right, you're back. Number 14, we're solving for y, so we're going to divide both sides by 4. Negative 16 divided by 4 is negative 4. Or you can write y equals negative 4. Same thing. Once you get used to the options that you have, but I don't want you to think that if I only write it one way, that that is the only correct way. All right, 15, to get rid of the divide by 5, which would probably bother most people, we're going to multiply both sides by 5. It's going to cancel out with the divide by 5. That's why we did it. W minus 6 equals 8 times 5 is 40. We're going to add 6 to both sides because that's the opposite of subtracting 6. So W equals 46. All right, 16, the opposite of subtracting 3 is adding 3. We have 2/3 y is equal to 12. We're not going to divide by 2/3. We are going to multiply by the reciprocal on both sides. The reciprocal of 2/3 is 3 over 2. This 12 is over 1 if you want to write it. 3 times 2 is 6. Over 6 is 1. They both cancel out. We get y equals, if you want to, you can simplify here, y equals 18. Or you could have 36 divided by 2, which is also 18. All right, the coordinate plane. I expect you to be able to graph things. Right now we're going to focus on points. The coordinate plane has an origin, which is right here where the x and the y-axis meet. The x-axis is horizontal. The y-axis is vertical. Our quadrants go in a clockwise fashion around, so clockwise, C for plane, coordinate plane. Origin is located at 0, 0. So I expect you to graph and be able to identify points in the plane. An ordered pair is just a location of a point. The first number is the x-coordinate. It tells you how far left or right to go. The second number is the y-coordinate. It tells you how far up and down to go. If the values are positive, an x-coordinate will go right, a y-coordinate will go up. If the values are negative, an x-coordinate will go left, and a y-coordinate will go down. Basically, it's an address. So we're going to plot the ordered pair on the coordinate plane, and you may have to get really good at drawing your own coordinate plane. And so what we're going to do is we are plot the ordered pair on the coordinate plane. Why is that one there? Okay, that's that. Okay. All right, so what we're going to do for V, W, X, and Y is we're actually going to plot them on the left plane. And then Z, we're going to use that right plane to answer that question. All right, so for V, we're going to plot -2, comma 2, and then we're going to put the letter B there. So we're going to start at the origin. Here's the origin. So don't think of that as a point, but think of that as where we're starting. And I'm going to go left 2 to go the -2, and then I'm going to go up 2, and right there is our point. And I'm going to get rid of all those lines, but that's the point that I'm going to label B. So -2, 2, there is B. All right, so for D, which I'm going to do in a different color, we're going to go 1, -1. So we're going to go right 1, and we're going to go down 1. So from 0, 0, we'll go right 1, we'll go down 1. Right here is the coordinate D. All right, F is going to be, we're going to go left 3, because that's what the -3 means, and we're not going to go up or down any, 0. So we're going to go left 3 and not go up or down any, and that is going to be F. And then sometimes we have to estimate. So that's where H comes in. We're going to have to figure out where a half is going to be going up a half. But we have to go right 4 first. So start at 0, 0, go right 4, go up a half, and you're right about there. We'll label that H. And then what order pair corresponds to point Z? Well, that would be over here, this point right here on this other coordinate plane. There we go. What order pair is that? Well, I start here at 0, 0. I get to the right 4, 1, 2, 3, 4. So to the right 4 would mean that I need a +4 as my X value. And then I have to go down 2. So because I'm going down, it has to be negative. And there we go. That is the order pair for point C. All right, so if you could hand draw a coordinate plane. So what that means is you'll draw a coordinate plane and you will need to number these 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4. You don't have to number all of them. 1, 2, 3, 4. Okay, But that is a good example of how I want you to draw a coordinate plane, especially if you have no graph paper. Try to make them those intervals as even as possible, but you do need to have something there. I cannot look at a picture that doesn't have and show what you count by. All right, so with that you need to draw, I want you to go ahead and do 17, 18, 19, 20, and then 21, we'll use this graph to get me an answer. So go ahead and do those problems. Pause the video now. All right, you're back. All right, 1, 3 is right here. That's A. 2, -4 is down here. That's C. -4, -2.5, that's about right there. There's E. And 0, 1 is right there. That's G. The order pair F, which is this one right here, is at 1, 2, 3, -3, 1, 2, 2. So we would have -3, 2. All right. You need to be able to graph one variable inequalities. We will work on solving them, but I need you to be able to graph them. So if it has a less than or a greater than, no equal to bar, you're going to have an open circle. If it has an equal to bar, a less than or equal to, greater than or equal to, you will have a closed circle. You will shade in the direction that the answers are going to lie in. So let's look at graphing some of these on a number line. So the very first thing I need you to do is to draw a number line. You're going to put some number on the number line. In this case, we're going to put -10. And for me, I'm happy with -10 being the only number on the number line. If you want to spend 47 years putting lots and lots of other numbers on there, okay, you can. You can put a few numbers on there. I just really need to see -10. Whatever it is that you need to put on there, go for it. All right, at -10, there is no equal to bar in the symbol. This is a greater than. So that means that there is an open circle at -10. Now you see how I have that circle around those tick marks? I want to see tick marks. I want you to draw the circle on the number line. Do not draw it above, draw it on the number line. It'll help you for later, I promise. We want numbers greater than. So think of this as all numbers greater than -10. Well, numbers greater than -10 live to the right of the number line, right? Zero's out here, 100's out here, a million's out here. Okay, so we want to shade to the right of -10. And you want to shade all the way down to the arrow. Do not stop before the arrow, because that means your answer stopped before the arrow. We want to go all the way down to the arrow. Now, when you look at these symbols and you have the variable over here to the left of the symbol and the number to the right of the symbol, this will point in the direction of the shading. That points to the right, the shading's to the right. Points to the left, shading's to the left. Points to the right, shading's on the right. But that's not true when we switch and we have the variable on the right, like in B, and the number on the left. So what you can do is you can learn how to flip these. So I'm going to trade sides and see how it's pointing to the X. I want to make sure that it's still pointing to the X. So when we actually get to these types of problems, I'm going to encourage you to rewrite them. Right, got a question for you. What number goes on this number line? The only number I need to see is 6. It's got a closed circle because it has an equal to bar. So make sure that that circle is closed and it's on that number line. We're shading to the left because it's less than. Numbers less than 6 are over here, like 0 and -100. Okay, so we shade all the numbers less than 6 or equal to 6. All right, so you're going to try draw me 2 number lines shaded with correct circles. Pause the video now. All right, you're back. I'll draw a couple number lines here. For number 22, you need to have 3 on the number line. It's mixed up. Ooh, let's fix it. Switch this, we flip this. It's pointing to the 3, so I need to make sure it's pointing to the 3. It's closed circle because it has an equal to bar, and because it's greater than, it's pointing to the right, we will shade to the right. All the numbers greater than 3 live out that way. Did you shade all the way to the arrow? All right, let's look at number 23. The number on here needs to be 10. It's an open circle, and we're shading to the right all the way to the arrow. So that's how I want you to graph inequalities on a number line. All right, you also need to be able to use formulas. Some of these formulas you learned in geometry, so we're going to blend some geometry with some algebra. A formula is a fact or rule that has an equal sign in it. It will have 2 or more variables with values that we don't know yet, and we may give you values to plug in, and then you use your order of operations to figure them out. So you should know the area of a triangle is the 1/2 base times height. You should know the area of a circle is pi r squared. And I expect you to know the Pythagorean theorem, although it's probably not going to be coming up anytime soon. But if you had trouble with the start of the year checkpoint with the distance formula, it's actually a form of the Pythagorean theorem. There are going to be some more complicated ones, like the area of a trapezoid. Now, if I was going to ask you to use that in maybe a homework problem, I would probably provide that for you. But if I was going to ask you the area of a rectangle, you might not get that formula. So here is our formula. They give us details. Area equals 1/2 the sum of the bases. They want the top base plus the bottom base, but we could flip that around and multiply it times the height. So here I have all the dimensions that I need in problem C to plug them in and calculate the area. So area equals 1/2. I'm going to use 3 as my little a plus 7 as my little b. And we're going to multiply that times our height, which is 6. And so then this goes into the order of operations that we were using in the beginning of the video, where we say parentheses first. But if you wanted to do distributive property, you could also do that, but you create some fractions. 1/2 times 10 is 5. 5 times 6 is 30. And when we talk units, we talk units squared for area. Area is always units squared. So if they give you units, you need to use them. I'm kind of a stickler for that. If they give you volume, or you're working with volume, volume is units cubed. If they don't give you units, then that's the only time that it is appropriate to not leave units. All right, so perimeter of a rectangle. Ooh, they give us the perimeter, they don't give us the width. Do you think you can use the perimeter of the rectangle formula to figure out the width? Pause the video, see what you can do. All right, you're back. So let's use this P equals 2W plus 2. I like to use uppercase L. So I'm going to do that. So I'm going to plug in what I know. I know 56 is the perimeter. Units aren't very helpful at this point in time, so you might not need them. I don't know W, but I do know L. 2 times 16. So we're going to do 2 times 16 and get 32. And then we're going to work on solving for W. So this is our two-step equation. So we're going to subtract 32. So that's going to be what? 24 equals 2W. And then to get rid of the multiply by 2, I'm going to divide by 2. So W equals 12. My units are in meters. This is a dimension aside. So we do not have to worry about, because this is an area in meters squared. A length and a width would just be measured in meters. All right. So you need to finish homework 0. This assignment is due Monday. Do not worry about turning it in until we talk about it. And I will show you where and how to submit it in our Google Meet Monday. But I expect you to have attempted all 20 problems by the time you come to the Google Meet on Monday. Do not come to the Google Meet without having looked and done and attempted these problems. Please, please, please do not get behind on the very first homework assignment. Please stay up to date with everything. You will thank me later. You do not want to be taking Algebra 1 as a sophomore, I promise you. Okay, you want to be in geometry next year. Okay, so let's do this together. Bring me any questions that you have. I'll see you guys in the next video. Bye.